Welcome back, and we are going to continue our study of testing for convergence and divergence with another test. So we talked about the comparison test, but now sometimes that string of inequalities gets to be really annoying, or it's like, okay, I know what it's supposed to be, but I can't show it using inequalities. That's where the limit comparison test kind of comes in handy. Okay, so limit comparison test says, okay, we have to have those conditions. Also, this upside down A, we read that in mathematics as for all or for every. So I do introduce some shorthand notation, just be aware of that. But anyway, if we have that condition of positive values in our sequences, if we look at the ratio of our two sequences, and that is C, where C is a positive finite number, then if we if that condition is true, then either the series both converge or they both diverge. So we just have to be aware of that. And BN, your choice of BN could converge, or if it diverges, then AN is going to diverge. That's really what it's saying. How do we find this BN? Be careful and clever. Okay. Sometimes looking at leading terms might be useful. Okay, we'll see an example here. Okay, so I'll do an example and then I'll leave you to do some examples. So we want to determine if this converges or diverges. Okay, here is our sequence. I'm just going to be lazy and I'm going to call all that AN. So I want to find BN, but I want to have some sort of intuition about all this as well. I'm going to say, well, BN is going to be BN. So if the 3n wasn't there, then the leading terms would be 2n squared over n squared, but the 3n is there currently, so I have to look at that. So it's almost like two series multiplied together into one. So I'm going to use this as my comparison sequence, and when I look at the limit, and I'll say both of them are positive and all that good stuff. If I look at the limit as n goes to infinity of AN over BN, that's the limit as n goes to infinity. Now I'm just going to write AN, so this is 2n squared plus 7n over 3 to the n squared plus 5n minus 1. Okay, then dividing by bn is the same as multiplying by the reciprocal, so that'd be n squared times 3 to the n over 2n squared. Okay, so then the 3 to the n's are going to cancel out. Okay, and then I'm left with this, and over time, what I would see is that this should approach 1, but I actually forgot to make one simplification here. Obviously, the n squares could reduce, so this is really the same as 2 over 3n, 3 to the n, and that could reduce here as well. And so this is also consistent with our understanding of limits, so we'd have long-term behavior, divide by n squared to each term, or prove this however you want using, the big potatoes and small potatoes ideas, but we get 2 over 2, which ends up being 1, which is going to be greater than 0, and then so according to the limit comparison test, if I get C as a positive finite number, which 1 is, then both of those either converge or diverge. Now Bn, as I look at this, if I look at the series of 2 over 3 to the n, this converges by geometric series. So then that implies that since limit an over bn is equal to 1, which is positive, that we get the series an, which I've defined above, is convergent by limit comparison test. Okay, so the big idea here is doing the limit isn't too challenging. It's finding the right choice of BN that could be a little tricky. Okay, and also make sure to simplify, as I did not immediately. Okay, so now for the next two, I want you to try these on your own. Pause the video and try them out and resume the video when you're ready to see the solution. And here are the solutions to those two exercises. So kind of following the same format. For Bn in the first one, I just chose 1 over n to the 4/3, and that one is conversion by p series, so then go through the limit, find it's 1, which is positive finite, so it converges by limit comparison. For the second one, now this one is a bit of a challenge exercise. You need to play with an a little bit, and then when you do, you recognize that it's approximately the same as 1 over n, and we know 1 over n is divergent by p series, so then as you go through the limit, and this limit is a little tricky, 1 over n to the 1 over n ends up being 1, which is greater than 0, so then since the 1 over n series diverges, then the other series is going to diverge as well by limit comparison. Okay, so kind of a standard example, then a trickier example of the limit comparison test. So just keep this in your toolkit along with the integral test and the comparison test to use to conclude convergence or divergence of a series.